All right, this is Unit 3, Lesson 2, the set section of the Ready, Set, Go practice. So for each for each graph and description, do the following. Use interval notation to state whether the function is increasing or decreasing, or excuse me, not whether, but where the function is increasing or decreasing. State the minimum or maximum if the function has them. And if it has both, I think we could state both. Write the domain and range using interval notation and respond to the context-based problem. And they didn't leave us a ton of room to do all of that, but we will do our best. So in number 7, we're given the context that this graph represents altitude in thousands of feet during a trip up and down the mountain. And I think what is on the x-axis got cut off, but that should be hours down there. So we have time in hours as our independent variable and altitude measured in thousands of feet as our dependent variable. So where a function is increasing, I'm going to go back and color code this differently. Where a function is increasing is that when I look at my graph from left to right, it's going up. So on this graph, this section of my graph is increasing. And then where a function is decreasing, well, that is when I look at my graph from left to right, my function is going down. So that happens from there to there, but then again, here as well. All right, so for interval notation, I'm going to write this underneath the question at the bottom. We could say the function increases. And for interval notation, it looks a lot like an ordered pair, and I understand that can be confusing, but I'm going to use parentheses to exclude my first and last value. So when I'm writing this in interval notation, I'm considering the values of x or t, whatever. I'm just going to use x and y for this. Sometimes we use t since we're measuring time, but I consider my inputs. So I want to say between what values of x is y going up from left to right. And so that's going to be from where x equals 0 until this point where x equals 5. And the reason we want to use parentheses, not brackets, is that at 0 and at 5, the function's neither increasing or decreasing in an instant, rather it's increasing over an interval. So I know this looks like an ordered pair, but from the context of what we are saying, we can tell this is an interval. Or sometimes I'll have my students in calculus write increases on, and that maybe makes it more clear that we're talking about an interval. So then this function decreases on the interval from where x is 5 all the way to where x is 20. Now, sometimes I'll have students break it up and say, well, we're decreasing from 5 over here to 12, and then again from 12 to 20. And if you did that, it would look kind of like this. And this symbol that looks like a U is a union symbol. And it just tells us that the graph is decreasing from 5 to 12. Technically, we interpret that symbol to mean or, but that means it's either increasing from 5 to, or decreasing from 5 to 12 or from 12 to 20. So again, these are not ordered pairs. These are values of x. And this is interval notation, and I know it looks a lot like an ordered pair. All right, then we're asked to state the minimum or maximum value. So these are going to be values of y. So in my graph, if I look at my graph, what is the greatest, the maximum y value? Well, that's going to be right here. And we could think of this as what we call an absolute maximum, meaning between the values of x equals 0 and x equals 20, and including those values, it is when x equals 5 that we have a maximum value of 11. So I'm going to write this. I'm going to say there is a maximum of y equals 11, and I'm going to just specify that happens at x equals 5. So the maximum value is the 11. 5 is the location where on the graph that maximum occurs. All right, then if I look for my absolute minimum values, well, the minimum y value that I see between x equals 0 and x equals 20 is the y value at y equals 2. And that occurs twice. It happens once when x is 0 and once when x is 20. So I could say that this graph has a minimum of y equals 2 at x equals 0 and x equals 20. And you could write that twice, or you could list that x equals 0, 20. So again, the minimum value is 2. The location where the minimum value occurs is at 0 and 20. So it occurs twice, but the minimum is still just the number 2. And I know that if I interpret that in context, that would be 2,000 feet, but I'm going to just use the value on the y-axis, which is the number 2. All right, then we're asked to write the domain and the range of the function using interval notation. So when we use parentheses, this is going to exclude values. When I use brackets, the bracket indicates that we should include those values. So remember, the domain is going to be the x values where the function exists. Oops, values, not values, values. And the range is going to be the y values, like from the minimum to the maximum, that occur over our domain. So let's look at domain first. And because I see this closed circle, that closed black circle, when I look on my x-axis, that circle goes right through, oops, I should use a different color for this maybe. That circle goes right through where x is 0. So that, because the point is solid there, that's a closed circle, we call that, I want my domain to start at 0 and include 0. If that were an open circle like that, then I would exclude 0 from my domain. All right, and then as I look at my graph, I don't have any domain interruptions, meaning there's not like a break in the graph or anything. So all the way over to 20, that's where my domain ends. And again, because I have a closed circle there, I want to go right through the 20. So my domain is going to be from 0 to 20, and I use brackets to include those numbers. Now for range, we do a similar thing, but we do it on the y-axis. So for my range, I could see my lowest value is that minimum value of 2. And again, I want to include the 2 because I have a closed circle there. And my maximum y value that I see on my graph is 11. So my range of values is from and including the 2 all the way up to and including the 11. So again, we use brackets there. All right, lastly, we're supposed to answer the question. So what is the highest altitude reached during the trip? So we said our maximum value is 11, but now that we're asked about this question in context, I think we should include units. So that would be 11,000 feet. And you could either say 11,000 feet like that, or you could write out 11,000 feet. All right, let's look at number 8. All right, so similar thing. We're going to start with increasing or decreasing. So when I look at this graph, it is increasing, well, not at the beginning, but from between these two values, this is where the graph is increasing. And right here is another place where my graph is increasing. My graph is decreasing. What color did I use? I should stay consistent. I'll use yellow. My graph is decreasing here and here and here. So when I list these intervals, I'm going to use this symbol. We said it looks like a U. It doesn't have a tail because it's not actually a U. But in set theory, we call this the union symbol. But we don't write it like that because it's not literally a U. Okay, so from the value where x is, let's see, 1, 2, 3 to 5, nope, to 6 rather, that's where my function is increasing first. So I could say the function, oops, I should leave a little room to answer that question. The function increases on the interval from 3 to 6. So again, with intervals of increase and decrease, we always use parentheses because at x equals 3 and at x equals 6, the function's neither increasing nor decreasing at that moment. It's just over the interval. But we said the function increases again, and that would be from 8, so like from where x equals 8, all the way over here to where x equals 12. So I'm going to join those intervals with the union symbol and say from 8 to 12. All right, the function decreases on, well, the other intervals. So from 0 to 3, I'm going to use the union symbol. Then again from 6 to 8, so everywhere that I have highlighted yellow. And then again from 12 to 16. Okay, so those are our intervals of increase and decrease. Then we're asked to state the minimum or maximum if the function has them. So again, on this closed interval from 0 to 16, the maximum value that I see is, well, the first value. So 5, 6, 7, 8, that occurs at y equals 8. The minimum value I see is at y equals 0 right here. So when I answer this question, I'm going to say that the maximum, oops, that's a little thick. Let me make that pen a little bit thinner. That the maximum value, I'm going to say max value, just to abbreviate, is y equals 8. And we said that occurs at x equals 0. So when x is 0, y attains its maximum or greatest value on this interval, which is 8. And then the minimum, or like the least value of y on this interval, is 0. And that only occurs one time at x equals 16. So again, the max and the min are values of y, and the x equals is just the location where those max and mins occur. All right, the domain and the range. So we said domain is all of the x values. And again, we have closed circles here. So from x equals 0 to x equals 16, that's where my domain is for this function. So domain is from 0 to 16. And then we said the range, similar idea, but we do it for our y values. So my minimum y value, we said, was 0. My maximum y value is 8. And again, I want to use brackets to include the 0 and the 8. All right, and then lastly, we said respond to the context-based question. I didn't even read the context yet. I should have done that first. The context of this graph is it's the distance from the shoreline of a fishing boat over time. So that fishing boat was 8 miles away. It looks like it got closer, then further away, then closer, then further away, then back to shore. So during which part of the fishing trip was the boat most quickly approaching the shore? So I'm looking for where its distance away is decreasing. So I'm really only considering these 3 decreasing intervals. And the question is, when was the boat most quickly approaching the shore? Well, we could really, something we could consider is the rate at which that distance is changing as we get closer to the shore. And y'all, that rate of change is just our slope. So if I look at these 3 yellow intervals, if I make kind of like what we call sometimes a slope triangle, I could see that for this first one, from 8 to 1, that I'm moving my delta y here is -7 over 1, 2, 3. My delta x is 3 there. So that would be -7/3 would be my slope for that part of my graph. Here, if I do a little slope triangle here, my rise is, or my delta y is -2, and my run, or my delta x, is +2. So -2 over 2, sorry, that's my ESPN app in the background. -2 over 2 is -1. And then lastly, for this last slope triangle, if I start at y equals 6, and I'm going all the way down to my x-axis, and then over 1, 2, 3, 4, I have -6, +4, and that slope is -6 over 4, which I could simplify that to -3 over 2. So the question is, of these numbers, which has the greatest magnitude? So if you just don't look at the negatives, is 7/3, 1, or 3/2, which of those is the greater number? Well, that's going to be 7/3, because 7/3 is the number 2 and 1/3, and that number is greater than the others. So I realize they're negative, so I could really say that's the least value. So that's going to tell us that that boat was traveling fastest towards the shore on that interval. So during which part of the trip? I would say from 0 to 3 hours, or the interval, like that's the interval from 0 to 3. So that is when the boat was most quickly approaching the shore. I know that problem's a little bit tough to think about. All right, on to number 9. We're going to do the same thing. So intervals of increase or decrease. Oh, this graph looks kind of funky. Ooh, I got to tell you, I don't like it. I don't like this graph. I'll tell you what I don't like about it. It's not super clear to me where this x value begins. I am going to just make some assumptions. I'm going to assume that this is a closed circle because I don't see an arrow and I don't see an open circle. But I will admit that it's not as clear as it was in the last question. And so, let's see. What is a tesseract? Oh my goodness, I'm going to have to look this up. All right, so I am not sure if this graph just gets cut off, but if I don't see an arrow. Ugh, I'm going to pause for a second. I'm going to look up what the word tesseract means, and then I'm going to restart this video from right here. Okay, so a tesseract is just a cube, which I knew, but I guess in the Marvel universe, there's some special cube that does something. I don't know. Okay, so here's the deal. This is not the best graph. I am going to go ahead with the assumption that if you look up here at the top right, how it gets cut off, let's just assume that this goes on forever. And I hope any graphs that I give you in class, I will either make that more clear or we'll talk about them. So we are going to assume that there's a closed circle here, but that let's just go ahead and think of there being an arrow there. So this curve that we see, we're just going to assume that that graph pattern continues forever that way. Okay, So maybe you've seen enough Marvel movies to know which one has some type of Tesseract energy cube in it, but I had to pause and look that up because it was going to bother me. All right, so going back to intervals of increase or decrease. So now my function, you don't know this yet, but this is what we would call a piecewise defined function, and it's just fine that you don't know that. But if I look for where it's increasing, I notice that it doesn't start to increase until x is 16, so like right here. So we have this linear segment, and then our function becomes a curve after that. And again, we're going to assume that that goes on forever. Over here, the function's decreasing from this very first x value until we get to where x is 16. So also, I just checked my answer key when I was Googling what a tesseract is. And let's just go ahead and assume that this does happen, that this is where x is 0.5. I know that that point is not exactly on one of our like faint axes marks. So it looks like it's halfway between 0 and 1. I'm going to move ahead with that assumption. We said this is where x would be 16, and then we said this is going to go on forever. So if I talk about intervals of increase, I'm going to say the function is increasing, or you can say increases on the interval. Well, we start where x is 16, and it's going to increase forever after that. So if we put an arrow there, we're assuming that pattern, that curve pattern, continues forever. So the way we represent this in with interval notation is using the infinity sign. So the infinity symbol looks like a sideways 8. And I am terrible at drawing it. Half the time I do it, it turns into looking like an 8. But this means from x equals 16 on forever in the positive direction, positive infinity. If I go forever in the negative direction, I write a negative in front. So I would think of that as negative infinity if I see the infinity symbol with a negative sign in front. Okay, and then the function decreases on the interval. Well, we said it starts at 0.5 and it decreases until x equals 16. And again, with interval notation, we want to always exclude those values because at x equals 16, that's where the function is changing from being decreasing to increasing. So I don't want to include that in either interval, since at 16, in that instant, the function is neither increasing nor decreasing. Okay, so that was intervals of increase or decrease. So then we were asked to determine if this has an absolute maximum value, a maximum value. And because this graph continues up forever, there is no maximum value. So no max value. However, the function does have a minimum value right here at y equals 0. So I'm going to say min value is y equals 0. And even though we weren't asked to do this, I think it's a good habit to say when or where that occurs. The location is at x equals 16. So when x is 16, we get our minimum value of 0. All right, and then lastly, domain and range. Second to lastly, we still have to answer the question. So again, we said the domain of this function is going to be all of the x values where it exists. So it begins at 0.5 and it goes on forever because this arrow, even though it's pointing up, like it's going up and to the right, that means that if I made this graph bigger and bigger and bigger, the function would never stop. It would go on forever. So how I can write that is I could say my domain is from 0.5. We said we're going to include that value in our domain. And then because it goes on forever, I'm going to use the infinity symbol. Now, with infinity, we always use a parenthesis because infinity is not actually a number, it's a concept. So it's just like one of those little nitpicky math things that when you have infinity in interval notation, we always use a parenthesis there. All right, and then the range we said is the same idea but with y values. So since our least y value occurs at 0, but we said that again, it's going to go up forever and ever and ever and ever, that my range is from and including 0 to infinity. So just to clarify, when I write my domain, these are x values. So this is infinitely to the right of my graph when I write that infinity. When I write my range, these are both y values. This is not an ordered pair. I'm just talking about intervals. So that's infinity going up forever. So those are similar, but a little bit different there because we're talking about x's or y's. All right, lastly, when is the change in the energy level increasing? Ooh, I don't like the way that's worded. The energy level, so we're told this is the energy level over time. So on the y-axis, this is energy level. Our x-axis is time. The change in the energy level is going to be like y over x. So for the parts of my graph that are linear, I could think of that as the slope, but it's asking where that is increasing. And that's the part of this question I don't like because I didn't think we were going to talk about that in this unit. Let me think about that for just a second. Okay, you know what? I looked this up and I realized that someone edited this question and it's poorly written right here. So not when is the change in the energy level increasing, but when is the energy level increasing? Let's answer that because otherwise we're getting into calculus if we talk about when the change of the energy level is increasing. So the energy level is increasing from 16 until forever. So we could say like from time, I'm going to use x since it was labeled. You could say t equals 16 until forever. That's not like the best way to say that. Or we could say on the interval from 16 to infinity. So it's really just asking us in context where this function's increasing, but I can't stress enough the way that was worded before was not mathematically correct for this answer. So let's make sure we cross that out. All right, let's see. And then we got a little bit more. We got one more question. So this one's a little bit different. Consider the table of values that represent a continuous function which models the amount of water in the tank that supplies drinking water to a town. That's a lot of words. Based on the information in the table, determine the desired intervals and answer the question. All right, so again, I'm going to read this one more time. We said this is a table of values that represents a continuous function. The function models the amount of water in the tank that supplies drinking water to a town. So we're given that water level or depth in feet. All right, so we have to be super careful in a table. I can only tell from my tabular data where I think my function's increasing, but that doesn't mean like they're values that are not represented in the table. So we want to be super careful with a question like this. So based on the table alone, I know that the water level is increasing from 24 to 30. I'm just going to maybe write out to the side increase. Now, here's the thing we don't know is that maybe between the first and the second hour, the water actually dips and then increases back up to 30. So again, like we really don't have enough information to answer this question, but we're going to do our best. All right, so then I notice after 30 that we dip and we start having less and less water until I get to 15. So from 30 to 15, or from x equals t or x, I'm going to call these x and y. So from x equals 2 to x equals 5, I can see my numbers are decreasing. And then starting where y is 15, again, I start increasing, like the y values start increasing again over this interval. So when we talk about our intervals where we're increasing, what we observe in the table, that's going to be from where x equals 0 to where x equals 2. So 0 to 2. And then again, from where x equals 5 to where x equals 8. All right, so again, we want to be careful. I can't stress this enough. We actually don't know this from a table. All I really know is that the values in my table are increasing, but we don't know what's happening between hours 5 and 6. Maybe the water decreases first and then increases. So we're just going to go on the table, but I'm feeling a little scratchy about the math in this problem. All right, from our table, we could see the water levels decreasing. We said from 30 to 15. So again, I want to use my x values. So from 2 to 5, we would observe that the water level in our table is decreasing. All right, the maximum, so if I just look through the tabular data, the maximum value that I observe is the number 25. Nope, I lied. It's 28. No, it's 30. Wow, I didn't do a good job of reading that table, did I? Sorry, the maximum value it appears to be is 30. I don't see a value in the table greater than 30. And again, I can't stress this enough. We don't actually know. It's possible that between hours 2 and 3 that there is actually more than 30 feet or the water level is greater than 30 feet and then it goes back down. So we're just gonna answer this based on the table. I'm gonna say y equals 30. For the minimum value, again, just based on what we observe in the table, I think the lowest number I saw was 15. So I'm going to say my minimum is at y equals 15. And then lastly, the domain. So we know the function's continuous, so I don't have to worry about like saying just whole numbers or something like that. But the only values we have are from 0 to 8. So for our domain, I'm just going to say from 0 to 8 because that is what is in our table. All right, so then in F, here we go. Are you completely certain that your responses above would be the actual value for the water level? If so, why? If not, why not? I'm going to tell you a hard no. No, and the reason is because the function is continuous, but only whole number inputs are represented in the table. Now, you could write something else there. That was just the sentence that came to my mind just now. But again, if we think about it, like we don't know, like between x equals 2 and x equals 3, it's very possible that like at, let's say x equals 2.7, it's possible that my water level is actually like 35 and then it goes down sharply to 22. We just don't know what's happening between those x values. So one way or another, we are not certain, like we cannot be certain. All right, that is the set problems.